Keeping up with the motto of our school, Thakur Vidya Mandir High School and Junior College, let learning be a joy and teaching a pleasure. Here we are with remote teaching and learning process to bridge the gap. Happy learning, students. Let us first revise what we have done in the last class. We did basic proportionality theorem. The statement says that if a line is drawn parallel to one side of a triangle and intersects the other two sides in two distinct points, then the line divides the two sides in the same ratio. You can see in the diagram given and to prove, which we have done in the last class. We'll be using this to prove the next two theorems, which are based on basic proportionality theorem. Let us prove the theorem, which is called as property of an angle bisector of a triangle. The statement of this theorem says that the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of remaining two sides. To prove this theorem, we'll first draw the diagram. As the statement says, the bisector of an angle of a triangle, will first draw a triangle. Let us name the triangle as ABC, and we'll take the bisector of angle ACB as CE, which intersects side AB at point E. Let us write down the given based on your diagram which we have drawn. So in triangle ABC, bisector of angle C intersects segment AB in point E, and we need to prove this bisector, that is CE, divides side opposite to the angle. So the side which is opposite to angle C is AB. It divides the side AB in two parts, which are AE and B. These two parts are in proportion to the remaining two sides. The remaining two sides are AC and BC. So what I need to prove is AE upon EB is equals to AC upon BC. We have again the statement given to prove and the diagram of this theorem, which we have already seen. Let us come to our to proof, which is AE upon EB equals to CA upon CB. There are two ratios which I have to prove equal. Now we have already done basic proportionality theorem, and this theorem is based on basic proportionality theorem. So I have to use basic proportionality theorem to prove this theorem. And to use basic proportionality theorem, we need a triangle, and in that triangle we need a line parallel to one of the side of the triangle. So we have a triangle, but we don't have any line parallel to any side of the triangle. So here, to do that, we'll do a construction. We'll draw a line passing through B, which will be parallel to C. And since we need to use this in a triangle, I have to extend CA, segment AC, let it intersect the line which we have drawn parallel to CE from B at point D. See why I have done this construction. Let us see our to proof. AE upon EB equals to CA upon CB. This is what we have to prove. From my construction, now I will be using basic proportionality theorem in this diagram. So if you see the triangle ADB, now I know in this triangle ADB, CE is parallel to DB. So can you tell me which ratio will be equal now? Yes, you are right. It will be AE upon EB equals to CA upon CD. Now we know from our construction AE upon EB is equals to CA upon CD, which you can see on the right hand side in yellow color, and what I need to prove is right on the left hand side in blue color, that is AE upon EB equals to CA upon CB. Now compare both the ratios and tell me what has to be proved now. Yes, you are right. You need to prove CB equals to CD. That means what actually I need to prove is triangle CBD is an isosceles triangle. I can see steps on your screen. That means first I need to prove triangle CBD is an isosceles triangle, and which is possible to prove only if we prove CB equals to CD. Now we have already used basic proportionality theorem in the given triangle, and we have got AE upon EB equals to CA upon CD. Now since we have proved CD equals to CB, I will replace CD, which is written in red color, by CB. So I'll get AE upon EB equals to CA upon CB, and that is what we need to prove. So these are 4 steps which are involved in proving this theorem. We'll be proceeding in the same way how these steps are. We'll first prove triangle to be an isosceles triangle by proving CB equals to CD, and then we'll be using basic proportionality theorem. We'll get those ratios equal, that is AE upon EB equals to CA upon CD, and we'll replace CD, which is written on in red, with CB because we have already proved them equal, and this will give me our 2 proof. Now let us see our sum theorem again right from the beginning. You can see the diagram which we have drawn. You know what is to be proved, that is AE upon EB equals to CA upon CB. For that we have already seen, if I use basic proportionality theorem in triangle ADB, we will get AE upon EB equals to CA upon CD. So you have already said me we should prove CB equals to CD. For that, triangle CDB should be an isosceles triangle, and how we can prove triangle as an isosceles triangle, we'll be using converse of isosceles triangle theorem. Now let us prove this theorem. How you will be writing it, you can see on your screen given to prove and the diagram, and this is how we are going to prove it. We already know I should prove first triangle CDB an isosceles triangle. For that we should prove CB equals to CD, which is possible if angle CDB is congruent to angle CBD. These two angles are not congruent to each other right now. They are congruent to some other angle. Let us see in our proof. We know C parallel to BD, where AD is a transversal. If C is parallel to BD and AD is transversal, angle ACE is congruent to angle CDB. They are corresponding angles. Now taking BC as a transversal, first we took AD as a transversal. Now if BC is the transversal, angle ECB is congruent to angle CBD. They are alternate angles. we already know from our given angle ACE is congruent to angle BECB, because C is an angle bisector. So from equation number 1, 2 and 3 we'll get CBD congruent to angle CDB, and if we have proved this, we have proved CB equals to CD. Now in triangle ADB, we know C is parallel to BD. If you remember in those steps I have said, we'll be using basic proportionality theorem. So we'll get AE upon EB equals to AC upon CD. Now I can replace CD by CB. We'll get AE upon EB is equals to AC upon CB, and that is what we need to prove. Let us prove the next theorem, which is based on basic proportionality theorem. Theorem is called as property of three parallel lines and their transversal. Let us see the statement of this theorem. Prove that the ratio of intercepts made on a transversal by three parallel lines is equals to the ratio of intercepts made on any other transversal by same three parallel lines. We'll first draw the diagram for this theorem. Since the statement says regarding three parallel lines, so we'll be drawing three parallel lines. First, line L parallel to line M parallel to line N. These are three parallel lines. Now we have transversal. There are two transversal in this theorem. First transversal T1, let it intersect line L, M, N at point A, B and C. Second transversal T2, let it intersect line L, M, N at point P, Q and R. Based on this diagram, we'll write down the given. As you can see in the diagram, line L, line M and line N, they are parallel to each other. T1 and T2 are transversals which intersect them at point A, B and C. T2 intersect at point P, Q and R. We need to prove the ratio of intercepts. Now see, what is intercept? It is a part of a transversal. It is a part of a transversal whose end point, it is a segment whose end point lies on the line to which the transversal intersect. So here for T1, the intercepts are AB and BC, and for transversal T2, intercepts are PQ and QR. So we need to prove AB upon BC equals to PQ upon QR. Now let us see how we are going to prove this. Again, you can see the given to prove on your screen and the diagram. As we already know, this theorem we need to prove using basic proportionality theorem. As I said before also in the last theorem, to use basic proportionality theorem we need two things, a triangle and a parallel line. Here in this statement we already have parallel lines but we don't have triangle, so we need to do a construction to get a triangle. That is why we'll do the construction. We'll draw segment PC which intersects line M at point D. Now see why we have done this construction. Now you can see triangle PCR in the diagram. Please see the diagram. In triangle PCR, what we know, yes, you are right, DQ is parallel to CR. So if I know in triangle PCR DQ is parallel to CR, then PD upon DC is equals to PQ upon QR. you can see the right hand side of this ratio PQ upon QR is also the right hand side of our 2 proof. We have got this from basic proportionality theorem. There is one more triangle where we'll be using basic proportionality theorem to get the next ratio, which is the left hand side of 2 proof, that is AB upon BC. That we'll be seeing in the next slide. Yes, let us start again from the starting. This is your diagram where we have drawn P segment PC as construction, and in triangle PCR we got PD upon DC equals to PQ upon QR by using basic proportionality theorem. Same way, as I said, there is one more triangle where we'll be using basic proportionality theorem, and that triangle is ACP. In this triangle ACP, we have BD parallel to AP. If I use that, I'll get PD upon DC equals to AB upon BC. You can see the right hand side of this equation is AB upon BC, which is the left hand side of 2 proof. We have got this using basic proportionality theorem. So the one which is there up in blue color, PD upon DC equals to PQ upon QR, and in middle PD upon DC equals to AB upon BC. We have brought both of them together. Now if you compare these two equations in blue and yellow, you can see here we are using transitivity ratio 1 equals to 2, 2 equals to 3, therefore 1 is equals to 3, that is 1 AB upon BC equals to PQ upon QR, and that is how we'll be proving this theorem. To see the theorem right from the beginning, given to prove, we need to prove AB upon BC equals to PQ upon QR. We have done one construction. We have joined P and C. Segment PC intersect at point D. You can see this proof on the screen. Draw segment PC which intersect line M at point D. We have taken two triangles where we have used basic proportionality theorem. The first triangle is ACP, where BD is parallel to AP. So we have AB upon BC equals to PD upon DC. And in triangle CPR, we know DQ is parallel to CR. Therefore, PD upon DC is equals to PQ upon QR. So from equation 1 and 2, we'll get all these three ratios equal, which gives us AB upon BC equals to PQ upon QR. And that is what we have to prove.